look at this question here. All right. This is calculation on. All right. This is calculations. Alright, so look at this question, Mike. What is the quantity of heat needed? What is the quantity of heat needed to raise the temperature of 20 kilogram of aluminium through 10 Kelvin? Alright, I'll try to rephrase the question again. What is the quantity or amount of heat? So you know that they are asking for Q here. Alright, and what is the unit of quantity of heat energy is joules. So they're asking for quantity of heat here. Alright, what is the quantity of heat needed, required? Another word for needed is required, to increase the temperature of 20 kilograms. So you've been given the mass. Alright, your mass equals to 20 kilograms. Alright, mass of what? Mass of aluminium. Alright, aluminium through 10 Kelvin. Alright, so you've been given your temperature to your change in temperature is, yeah, you can quickly take it fast. So your change in temperature is 10 Kelvin. Alright, so they raise it through. Alright, so they've calculated the change in the temperature, and then they've raised it. They observed that the change in temperature was 10 Kelvin. Alright, so we're giving specific heat capacity of aluminium to be 900 joule per kilogram per Kelvin. So how do we now calculate this? It's very simple. The formula is, you remember the formula, Q equals to MC change in theta. Alright, so your Q is equals to your mass. Your mass is what? 20 kilogram times your specific capacity of aluminium. This is your C. Alright, so because you're dealing with aluminium here, you're going to use the specific capacity of aluminium. I told you every substance has their own specific heat capacity. So this is aluminium that we're dealing with here. So times 900 times the change in temperature is what? It was raised through 10 degrees Celsius times 10. So this becomes your 20. 2 times 9 is 18. Then you have 0, 0, 0, 0. So this should be 180. Sorry. 180 joule. So your Q is equals to 180,000 joule. So if we can change, this is 180,000 joule. Can you see this part from the video? Yes. Okay. So you can also change it to 180 kilojoule is the quantity of heat energy. 180 kilojoule. So that's the first question. All right. So that's the answer. So you only pause it. Let's solve another question. The center. Yeah. All right, Michael. So look at this question. The next question is, what is the quantity? All right. So the quantity again. What is the quantity Q that will be given out? All right. That will be given out if a bar of brass. A bar of brass is like a bar of brass, like a brass. Here you get a bar of brass. This is your brass. Your brass, you know your brass is a metal. The brass of mass 350 grams is cooled from 95 degrees Celsius to 20 degrees Celsius. So if you cool a particular metal from 95, from this temperature to this temperature, what is the quantity of heat energy that will be given out? All right. So you can solve this together by using the equation. Q equals to MC change in theta. All right. So you have your specific capacity of brass as we give you 380 joule per kilogram per Kelvin. So you have your quantity of heat. Q is unknown. All right. The mass of the brass is M equals to 350 grams. So you have to convert this one to kilogram, which means that you're going to divide by what? By 1000. So if you divide by 1000, it's going to give you, that should be 0.35, I guess. 0.35 kg. Alright, 0.35 kilogram. Can you see this clearly? This, alright. So that's 0.35 Kelvin. Alright. Then the specific capacity of brass is here. C equals to 380 joule kg minus 1 K minus 1. And then your change in temperature, 95 to 20, that should be 95 minus 20, which is going to be 75 degrees Celsius. That's the change in temperature. Alright, the difference between the two temperatures is 75. So we do Q equals to the mass is going to be 0.35 times the specific capacity is 380 times your change in temperature, which is 75 degrees, which is 75. So we multiply everything. 0.35 times 380 times 75 should give up 9,975 joule. So that gave us 9,975 joule. But if you were to I think that's okay. But if you were to convert it to kilojoule, let me emphasize on that. If you were to convert it to kilojoule, you just divide by 1000. So this should be 9.975 kilojoule. 9.975 kilojoule. Divide by 1000. Divide by 1000. Yeah, I'm correct. It's 9.975 kilojoule. So now, one of the questions you could have asked me is the change in temperature is from this to this. Alright, so this is the final temperature, this is the initial temperature. Nice. So it's final temperature minus initial temperature, which is 95, which should have given us minus 75. Yeah, it should have given us minus 75. Alright, but we don't use we don't consider a negative here. Like we don't do the reverse. We just find the change in temperature. Alright, and once we get the change in temperature, we get the change, the quantity of energy. We don't get a negative quantity of energy. Alright, we don't get a negative amount of energy. So that's actually why we didn't use minus 75, that we used positive 75 plus 75. Alright, so that's that for this question. Stop it, pause. Alright, good. So calculate the final temperature of look at this question. It says calculate the final temperature. Alright, so you are looking for theta 2 of 2 kilogram, alright, of alcohol at this temperature when this is 20,160 joules of heat energy is added to it. Alright, so you have alcohol of mass this, alright, having a temperature of this, alright, and then they now added this quantity of heat energy to it. Like you have alcohol inside a cup of coffee, inside a cup, a steel cup, alright, that's a metallic cup, what the alcohol is in it. You now heat it up with this amount of energy, 20,160 joules of energy. So they said, what is going to be the final temperature? Alright, what is going to be the final temperature of the alcohol inside the steel cup? So this is how you're going to do. You're going to say Q equals to MC change in theta. I'm sure you remember the formula. That's the formula we've been applying since. This is formula for the quantity of heat energy, generated or added to the alcohol. So this becomes Q. Of course, we've been given the quantity of heat energy supplied. That is 20160 equals to the mass is 2 kilogram. 2 times we've been given the specific capacity of alcohol. I told you every substance has its own specific capacity. Now you can see 2520. All right, now times the change in temperature will be theta 2 minus theta 1. All right, so now it was here before. Calculate the final temperature. So you have to calculate the final temperature theta 2. This is the initial temperature that it was before. So you change the theta 1, you change it to 25. Good, 25 degrees Celsius. You don't need to convert it to Kelvin. It all still means the same thing. So 21060 equals to let's see, that's gonna be your 2520 times 2. So you open the bracket, it becomes 20160 equals to 5040 theta 2 minus 5040 times 25. So this is 126,000. So I make this one set of the formula. So I want to bring it up so you can see it clearly. I need you to check if the video is still there. So this is 2. I'm bringing it up, alright, so you can see it clearly from here. So this becomes 20160. This comes here, it becomes plus 126,000 equals to this here, which is 540 theta 2. 5040 theta 2. Alright, I hope you can see it clearly. So I will just add this to this, then divide both sides by this. So it becomes 20160 plus 126,000 equals to 146,160 equals to 5040 theta 2. So I divide both sides by 5040 by 5040. Alright, so I'm dividing by 5040, so divided by 5040. So my answer is 29 degrees Celsius. So theta 2, can you see my hand here? Can you see this my hand here? What I'm writing here from the video. Alright, theta 2 is 29 degrees Celsius. So this is the final temperature. When we now added this amount of heat energy, alright, the temperature increased to 29 degrees Celsius. And so what do you think is the change in temperature? The change in temperature is going to be what? 29 minus 25, which is 4 degrees Celsius, was added to this temperature when we added this quantity of heat energy. So just ensure that you solve as many questions as possible on from the all-inclusive physics. Alright, check the all-inclusive physics. There are many questions. So the next video I'm going to be sending to you is calculating the definition of thermal capacity. Alright, thermal capacity, we just did specific capacity. I'm going to give you a video on thermal capacity and how to calculate thermal capacity. Then we'll quickly go to electrical mixtures. Alright, it's possible for you to add heat to a particular substance through electrical means. Alright, for instance, that's what you use in your house. You get your boiling ring, you plug it to the wall, to your socket, alright, and then you put your boiling ring inside the bucket, you put your cold water inside. Then you observe that within 2 minutes or 3 minutes or 1 hour or 30 minutes, you observe that your your water is boiling already. It's at 100 degrees Celsius. What has happened? How come there is a transfer of heat energy from just an ordinary boiling ring plugged into your water, and then your water that was 0 degrees Celsius, very very cold before, or was ice before, is now having a temperature of 100 degrees Celsius because it is boiling now. So those are the videos I'm going to be shooting with you next. Alright, thank you. So just ensure you read very well.